Good morning, afternoon, or good evening, folks. I'm your host and guide, Chris Roberts. I'm going to take you on a tour of the underground to help you prepare for what's really out there. Whether you're on the front lines battling the latest threats or leading the overall defensive strategy within your organization, my focus is to help you uncover the best ways, means, and methods to effectively and efficiently use actual threat intelligence within your company, providing you with more insights and practical ways to identify threats and reduce risks before they become incidents. Ready to dive in? Good morning, good afternoon, and good evening, depends where you're coming in from. Welcome to another episode of the Dr. Dark Web with the two of us, both Danny Wolf and myself. We're doing another top, I want to say it's a top 10, but it's a top 10-ish, because I think it's like a top 17 in this case, if we get through them all. A 10 and change.
Yeah, I love it.
And we're doing it on the wonderful world of artificial intelligence and machine language. And we're going to, as nice as I can put it, I think we're going to take it to the cleaners as friendly as I can put it on this one.
Buzzwords and acronyms. Yay!
Oh my good grief. If ever there was something, actually, you know what we do need to do? I suddenly thought about it, and I'm not putting it on the list because I don't want to do it. But I do want to do it, so it might have to go on the list, which is a top 10 for quantum. Because you know it's coming. You know there's vendors out there which are already going, well, we're quantum proof, or we have quantum engineering built into our architectural solutions and our engineering principles.
Well, I'm down, obviously. But okay. Let's talk about what you've got in your hand right now. For those listening, it looks delicious. And we always promised that we would talk drinks on the podcast. So before we kick it off.
It's been one of those days. It's actually not been a bad day. It's been a fairly good day, an amazingly productive day with the Boom folks, and then got the commuting car sorted out. But we've had a technologically challenging evening, and it's totally my fault. My poor little Yeti mic has decided to jump off the cliff backwards with no parachute. And I spent about 20 minutes looking for these bloody questions that we're about to go through. So while we were off air switching between Zoom and the Squadcast stuff, I poured myself, this is called Boston Black Ops. And it's an Imperial Stout, so a crazy dark beer. And you can see it almost leaves like a viscous amount on the glass. And it's an Imperial Stout, but what they do is they finish it off in 4 Roses small batch barrels. So you've got Imperial Stout and bourbon all in the same rather yummy glass. Hence the reason it's in a very small glass, because if you drink this by the pint, your brain and your legs will soon be separated.
Well, you enjoy that, and I will cheers you to that with my wonderful half-empty cold cup of Taster's Choice. Taster's Choice coffee, which is, I don't mind cold coffee, actually. I'll just pretend like it.
You know what I need to bring you? Try to remind me when I come over for Cyber Week. I will bring you some of the Black Rifle coffee. It's, I'll probably actually bring Black Rifle, and I'll bring Death Wish coffee. I'll bring up a bag or 2 of each. Both are actually rather fantastic, and both actually really, really nice because they support charities and all sorts of other good folks, which is actually rather nice to see.
That's nice. It's interesting to know or to feel what that would do to you based on the name. So anyway, okay, good stuff. But before we kick it off, so it's been what, almost a month since the new role started?
Yeah, this is week 4, and they think so, 1, 2, 3, I think it's week 4, something like that. They paid me. I got paid at the end of the month, so they must actually be okay with me, because money actually arrived in the bank account, which is very, very civilized of them. And yeah, it's still good. Still actually rather fantastic. Had some amazing conversations. Ironically enough, had some really good conversations. I was showing Charles today some of the stuff we're doing on the threat intelligence, because obviously when you get in there, first thing you want to do is figure out what you're dealing with. It's that whole, know your landscape, know your environment. So literally the first thing I did was break into our internal system, break into our external stuff, and then try to figure out who the hell was talking about us. And, it's all using the data. It's all using intelligence. It's all listening to people and talking to people. So that's been fantastic to do, doing some compliance, regulatory stuff. They're putting me in front of the board in about a week and a half's time 2 weeks time, something like that. So that's actually gonna be really pretty awesome. Yeah, nice, good people, like good people, good company, good folks. And on the plus side, it's really nice to not be in the vendor side of the world for a change. It's a really weird feeling because it's been like 15 plus years since I've been on that side, but it's actually really nice to not be there. On the downside, as you are well aware from your other podcastings and musings on the internet, I do feel like my carcass has been well identified and being picked over on an almost hourly basis by whatever vendors in our industry are targeting me at that time.
Right. Right. Well, we obviously have a nice time unfolding and unraveling all those wonderful stories off of Dr. Dark Web, but we'll keep it for there. But one question I have for you, right,
Yeah,
before we go into the wonderful, wacky world of AI and ML.
yeah.
For those who are phasing into a new role in security, what is number one top kind of priority or tip or piece of advice you could share with somebody before starting their new role and going into that position?
Know the people. I think that's probably the biggest thing for me, and it's probably been the biggest help, and it's also, in some ways the biggest challenge, but I think less so where I'm at, it's a perfect example today. So I'm on a meeting and we're talking about the new website. So Boom is going to be launching a new website, and I ran a couple of checks against it when we found out about it, ran a couple of checks against it, and came up with a short list of things that we need to have a conversation with. And then the conversation goes to be, well, who owns it, who's managing it, who developed it, who put together. End up talking to like my peer on the software side of the world, and they weren't aware about it either because it had actually gone outside of the organization. So rather than go, okay, what I did was like, hey, would you like to be part of this conversation as we tackle the conversation about how to, and he was like, oh, hell yes, I'd love to be. I've got some ideas. I'm like, brilliant, let's talk. And then he was like, hey, I'd love to just sit down with you. And do you want to sit down officially, or do you want to just go out and grab like lunch or whatever? I'm like, let's go grab lunch. And so all of a sudden, you've got typically two very separate areas of technology, software development and information security, coming together to collaborate and work as a team to fix something. I mean, it's being able to do that at a human level. So there's no tech, there's no policy, procedures, controls. It's just humans wanting to do the same thing right. And it's really, really nice to do that. And same thing with the people, and various other folks inside the organization. Okay, Perthwood one. Sorry, squirreling for a minute. When your CFO comes up to you and goes, hey, I don't know enough about your industry. I want to learn more. I mean, you just want to hug them. You literally just want to wrap them up, hug them, and tell them, I will do everything in my power to help you understand enough so that I enable you, you can have the conversation. I mean, that's one of those things that's absolutely fantastic. And to some degree, it's unfortunately too rare. But Charles, who's my boss over there, has done an amazing job of kind of like opening up IT and InfoSec and everything else to people to allow them to make us more approachable. And you got somebody on the meet comes in and goes, yeah, what do you want to know? I'll sit down with you any time of the day or night and just help you learn. So to me, it's all about people. It's not coming in and going, oh, I've got technology, or I'll bring in McKesson or D&B or somebody else to help me understand. It's sitting down and going, hey, who are the people? How can I best work with them? How can I best, enable them, facilitate them, use them, all of these other things. And then we're all in this together. So that's been probably the most fantastic part about this. And something I would tell somebody else to do is go in, learn the humans.
I love that, and I think that's a recurring theme here on this series and in others, in other podcasts that I'm listening to is bridging that the technical really it's the human element
Yeah.
first and foremost. It's about the people, that's been stated on every C-suite live episode we've had and in the Geek Week episodes as well. So this is awesome. Awesome. Well, congrats on month 1.
Thank you.
You made it through alive.
So did
Uh,
they.
Yeah, so do they. Amazing. So Chris, what are we talking about today? What are the questions that we're gonna be running through, and why are we running through these questions?
Ooh, so I think we're going to run through them probably again back to the human element. When we look at technology, unfortunately, it doesn't matter where you are in this industry, you can't always know everything about everything. As much as you want to think you do, and as much as you're really good in certain areas, you can't always know everything. So what you have to rely on sometimes is the knowledge of whoever's presenting it to you. And this is a perfect case: artificial intelligence and machine learning. And this is one of those where those, we've talked about sometimes just straight machine learning. We've talked about artificial intelligence. We talk about all these other kinds of models as to where a computer can either help us, augment us, or in some cases take over from us. And unfortunately, the meaning has been lost a little bit. The knowledge as to how to ascertain what is and is not correct in the industry has been lost. And we've unfortunately relied a little too much on some of the sales and marketing and some of maybe the less scrupulous people in our industry trying to explain to us exactly what they've built. When you think about it, if I ask a computer to do something, it'll do it, typically without fail. If I help a computer to learn to do something very specifically, it'll do it, and it'll continue to do it almost to a fault. If I give the computer some parameters and say, I need help, if I've built my parameters correctly, it will look at me and go, here is how I can help you, and it will help me. And that's really the difference between just, regular programming, machine learning, and intelligence. And there's very subtle differences in there. But what we've done is we've kind of blurred the lines. And we've blurred the lines and said, hey, I've built this amazing engine. I've built this amazing platform. And rather than say, hey, I've built it and it can help you, they've gone, well, I've built it and it's, fully artificial intelligent. Well, no, it's not. Because it's not going to wake me up in the morning, decide I need a good cup of tea before I do. Neither is it going to read the news to me while I'm brushing my teeth and sitting in the bathroom. And neither is it going to do the 10 other things I need to do before I can sit and do work. It is a very narrow focus, and I think this is where a lot of times in our industry we get confused. When we think of artificial intelligence, Hollywood has done an amazing job, as has like the Marvel Universe and everything else, of building this amazing autonomous system that can think for itself and do everything. But what we really have is something like, IBM's Deep Blue, which is amazingly good at a very, very narrow focus. It can beat the crap out of you at chess. It will do an amazing job of looking at your logs and monitoring. But if you ask it to make a cup of tea, it's just confused as hell. That is a very narrow focus of AI. And we haven't done a good job in the industry of boxing our commentary in to help people understand that. We're like, hey, here's a solution. It's wonderful. But what it really is we just coded it, put some fuzzy searching on each end of it, and crossed our fingers and hoped it would work okay. That doesn't help. So really, the episode today is to try to do a couple of things. One is to actually get people to think, kind of like we did in the previous episode. It's not just go out there and buy the technology, but take that step back and go, why am I doing this? What's the logic? Which is kind of where we get to that first question, which is, do we actually need an artificial intelligence solution to solve our problem? And what is our problem? Is it a very narrow focus problem? And maybe you could use some machine type help. Or is it a wider problem? You're going to have a bit of a trouble doing that.
Are you ready to kick it off?
Yeah, I'm good to kick it off. Let's go through the 10-ish questions. So, first and foremost, let's start with the introspective view, which is, do we actually need artificial intelligence to solve our problem? And I think this is where I ask, if I've got a vendor in front of me and they're telling me they got this amazing technology and solution, I'm going to turn around first and foremost and say, do I actually need it? And that's somewhat of an introspective look at this and go, hey, have I identified the people? Have I identified the process? And this is the technology, but what process is broken? So a perfect example would be security operations, network operation centers. The process is broken because we're having to monitor more and more stuff. and it's sending more and more logs in, and we don't have enough eyeballs. So that process is broken because we're missing good stuff. So you use a very narrow set of intelligence, either machine learning or AI, depends on how you want to look at it. You use a narrow sense of of intelligence to go, hey, I see point A, and it's a problem, but is it one problem or is it lots? And I see these other points, and can I cross-reference them and correlate them? And it's got its own weighting, it's got its own scales, and maybe you give it a playbook and say, hey, I'm going to let you do certain things within these constraints. Now you've identified you've got a solution to your problem. Welcome to security orchestration. That is a good implementation of kind of AI, ML, stuff along those lines. If you're looking at the vendor's going to listen to you and go, hey, I have something that can help you here and here, i.e. security orchestration, or maybe something that can take your data quagmire and turn it into usable, actionable information. Back to threat intelligence. I can take an entire massive amount of data, I can apply an intelligence platform to it and give you actionable intelligence. That's great. Crappy vendor is just going to sit there and tell you all the wonderful baubles and bells and whistles and crap that their machine learning AI algorithm has, but isn't going to focus on how they can solve your problem. So that's really the first one, which is listen to what you need and then ascertain whether that vendor's actually kind of the right one in front of you. Now, let's use intelligence again. If the knowledge that I have of my company can fit on a Post-it note, like, one of these things, the chances are you're not ready to take the vast sum of information and turn it into actionable intelligence. If, however, you've sat down and gone, where's my key data? Who are my key individuals? Where are my key processes? What would kill me off inside 24 hours, et cetera, et cetera, et cetera. And you've got a reasonable amount of information. In other words, you've got quantity and quality of data. Then you have a decent chance of actually being able to sit there and go, look, I have a sufficient amount of data to train an artificial intelligence model. Because remember, you don't just throw AI at a problem and go, you'll solve it. Despite what the vendor tells you, you've actually got to do some training. It's no different than security orchestration. If you put an intelligent system at your entire data set of all your logs, it's going to be like, I don't know what the hell you want to do. So you have to train it. You have to tell it this data is important. You have to give it a playbook that says, if you see this kind of stuff, do these things, and let it build from there. So that second point is, do we have sufficient quantity and quality of data? Quality being a key one. If you're sitting with a data quagmire, you ain't got quality of data. If you've actually understand the data you have and you can refine it effectively, then really you're going to be able to more effectively implement an AI ML type solution. So one of the other ones, problem question number 3 is, let's talk about where you apply AI and ML. If you're looking to solve, let's say, a financial conversation, so, you run a financial institute and you want to model financial data and you want predictive analytics run on like the stock market, you want somebody who understands that type of data. You want somebody who understands those models. Just the same as us in our industry. If you're going after an AI ML type solution in security orchestration or in heuristics or in user behavior analytics, you don't want somebody who's taken IBM Watson. You don't want somebody who's taken Watson and gone, we'll make it work. We'll make it work is not a good way of dealing with it. You want somebody who's to some degree got a good track record. They have domain expertise in the very field that you're working on. Sounds kind of as if we shouldn't have to point this out, but we really do. I see too many AI and ML solutions where they've taken it from like the financial sector or the quantitative sector, or they've taken it from just pure data science and gone, it'll apply to security. No, it doesn't. It really comes down to training. It really comes down to understanding. It's a technical undertaking. It's knowing, how do I break the data down? It's knowing, how do I apply any kind of data model to the data? It's knowing how I understand that it's not a generic AI style model. that there's learning, there's algorithms, there's knowledge, there's data behind it. So that's a huge, huge business. You need to find somebody who's actually got domain expertise. Now, let's talk about the next one, which is what's the delivery model? So when you look at a delivery model, sometimes, and depending upon the type of data you're using, sometimes the wonderful world of the cloud comes in. By the way, we're going to do a top 10 of the cloud next because we're going to need to do it. But you're going to have these delivery models where somebody says, here's our engine, and we're going to apply it to your data. We're just going to point it at your data and good luck with it. Or there are some which say, hey, we're going to basically build our engine into a platform on site, on premise for you. We're going to take a look at maybe, are they doing general training? In other words, the cloud is a perfect example. That engine is spread across 100 different clients. You're just one of them. And therefore, their model is somewhat diluted by inputs and exports from clients versus what you see. Antivirus and heuristic vendors are infamous for this one. So just because you've got an AI solution in your AV, it doesn't mean that it's actually for me. It means that maybe you've got 100 financial vendors and only one aerospace vendor. Well, that data model is going to be very, very skewed towards what the financial sector wants, not what I want. So you really want to take a look at where that engine is, how they're using it, and then how they're delivering data results to you, data expertise to you, experience to you, playbooks to you, all of these other things. And then the other part that kind of goes with that, the other part that goes with that, to be perfectly honest, which is also what help are they going to be? When you talk about a delivery model, is it the Google Amazon model, which is like, hey, here's our AI solution, enjoy yourselves, have at it? Or is it more of a customized solution, which is, hey, we will hold your hands. We will have professional services that will work with our model and your data to effectively provide that solution. So really take a good look and see what the heck is going on as far as that one goes. Now, that's delivery model. Let's talk about training. Let's talk about how do we train that solution. This is an interesting one because, again, not all AI ML models fit all solutions. Sounds kind of strange, but perfect example. I went out today to have to go buy a vehicle for commuting. I didn't buy a sports car. I didn't buy a high performance crazy vehicle. I didn't buy an SUV. I didn't buy a truck because it didn't fit the model. What I bought was something that would work effectively within my solution. It sounds kind of easy, but all too often we get distracted. All too often we don't necessarily ask, what and how have you trained your solution? How have you fit what you're doing into my model? Training is a huge thing. Training data models, training data science. If you have a security orchestration model, how much are you training it? And then quite honestly, how often are you retraining it? Is this a once and done? Or is this a trailing 30 days worth of data? That way you can pick up trending. Is this a trailing 90 days worth of data? Now you can pick up subtle trending. Is it something that gets refreshed once every periodic time? So when you start looking all of this, you've really got to understand, because if you think about it, an intelligent system feeds off of data, feeds off of intelligence, feeds off of information. Doesn't just feed off of the raw underlying stuff you're giving it. It's got to learn. It has a thirst to learn. So how are you continuing to train it? Is it your own data? So it starts off blank and good luck and you're training it with your own data, or have they already modeled it on generic data? How often do they refresh that generic data? And then from a compliance standpoint, if you're sending your data somewhere else, how is it being looked after? Who's looking after it? Do we have compliance? Do we have regulatory? Do we have ITAR type of issues or challenges with that? So this is one of those things where you need to understand, again, who and how is it trained? How is it being trained? And how often is it being, I wouldn't say retrained, but how is it, being looked at effectively? So let's talk about interpretation. This is a really, really interesting one. We need to do, so two things typically come up. Interpretation is a very simple one. Transparency. Can we ask, how does it work? Don't tell me it's AI and it's magic in a box. That ain't going to cut anything with me. Invisible processes, to quote a very good friend of ours. Or the other part of it is I need to understand why it made the decision it made. So again, if we take orchestration, if all of a sudden I'm working and the entire internet gets cut off in my company because I gave my security orchestration artificial intelligence model the ability to do that, first and foremost, I want to know why. Is it something actually that it reacted to effectively? So I need to know how well I can drill into what triggered it, why did it trigger it, how did it learn that, why did it learn that, what was the learning model, what was the action it took, and why did it take those actions? But I got to understand if it's going to happen again. I got to understand what the criteria were, and I want to know if it was right. And if it wasn't right, how do I educate it effectively in some other way? So, again, back to the training, back to a decision matrix model and various other things. It drives me nuts when we get these AI companies that be like, oh, it's artificial intelligence. It's above your pay grade kind of attitude. Love you all dearly, but I want you on a whiteboard with the mathematics behind this because I studied quantum mathematics. I got you covered. Let's talk. So that's what I want to have is I need, and everybody that's listening to this, you have to understand how does it work and why is it making certain decisions to a level you are comfortable with, if that makes sense. So, and because at the end of the day, you are handing a level of responsibility over to a system. To some degree, it's no different than a human. Danny, perfect example. If you're coming into the organization to run basically my entire threat platform, guess what? We're going through an interview. And that interview is going to ask you, what's your methodology? How do you work? Why do you work that way? Give me your thoughts. Give me your criteria. How do you evaluate? How do you train? How do you change? How do you understand circumstances? The very engine that's doing that role for me, I need to understand that on a continual basis.
So I'm going to interrupt you here because this is an interesting set of questions. And at what point do you hand it off, right? You hand it off
Yeah.
to the machines. What does that look like? Because I was having conversations with some connections of mine, running the security operations for specific, financial services companies. And, they mentioned you're never going to get 100%, at some point we're going to have to hand it off to the machines to help us understand, you know, what we can sift through, right?
Mm-hmm.
And what does that look like? At what point, take me through a little bit of an example of, in your opinion, at what point should you hand it off to AI and ML?
So there's a comfort level. Part of it, part of it is simple human capabilities and capacity. We have been outpaced at this point in time by machines and their ability to make decisions faster, quicker, and arguably more effectively than we can in certain circumstances. Let's go back to threat intelligence or security orchestration. And we had an amazing conversation the other week with one of the Intel advisors who basically said, look, I have to search for the needle in a haystack. I'm going to have a machine help me take that haystack down to something manageable where I can just look for the nuggets. It's gold panning. You start with a mountain, you end up with a little bottle full of gold. To get to that, you've got to sift and sift and sift and sift and sift. Some of those tiers of sifting can be done more effectively by a machine, as long as you've trained it. Security orchestration is, in our industry, another really, really good use of that, which is I, as a human, cannot keep up with the amount of alerts that are coming into the system, let alone the individual alerts. I don't have the capacity or the capability to actually cross-reference those to see if there's a pattern, to see if something hitting point A is also affecting something at point C, D, E, F, and G. A machine, if it's trained effectively, can do that for me and give me a prioritization. So some of it comes down to just simple mechanics. We as humans don't operate fast enough. So you want to put a machine architecture in place to help you sift that out, to help you go from the mountain to that little pile of gold. That to me is where it comes in amazingly helpful as long as you've trained it. The other type as well is we need a little bit of hubris. We need to actually take that step back and recognize that sometimes we're not as good as we like to think we are. I can't stop everything from coming into a network. No human can. But I know if I train a machine effectively, the machine stands a better chance of spotting the anomalies than I do. So that's where, and documentation, if I'm searching for something or I'm looking for something or I'm looking for a pattern, if I train that machine, it can look for it more effectively than I can. So for me, it's a part of it as a human when I get overwhelmed. Part of it is just simple mechanics. There aren't enough of us to go around. Therefore, how can I actually help a machine to make me more effective? And part of it, you just have to recognize that. It literally comes down to the fact I can't operate effectively because I got too much to do. How do I change that dynamic?
Yeah, that's awesome. I love that answer, and I've been itching to ask it during your flow here. So I will shut up now and let you get back to your business here.
No, that totally awesome questions. Totally awesome questions. All right, so here's a fun one. Here's a fun one and a very, very scary one. Shit breaks. So if it's breaking, who's liable? When it breaks, who's liable? And this is really where it gets kind of interesting because you've got to actually take a step back and go, it's the what happens if, and it isn't necessarily a legal conversation. It isn't necessarily a business conversation. It really is, how do we recover from it? And this is, to some degree, there are lawyers involved, there's business involved, but I want to know what you're going to do when it goes wrong. I want to know that you are alongside me. I want to know that you and I together, our teams will work effectively to mitigate, will work to effectively understand, will work to construct and reconstruct. We understand the consequences, the visibility, and it isn't a blame game. It's like, hey, how do we get through this? How do we learn? This is where the NIST incident response plan comes into place. So that to me is a huge one. When a vendor says, oh, it won't break, it isn't break, there's no risk, blah, 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 that's when I start throwing red flags left, right, and bloody center. When somebody goes, hey, give me a call at 2:00 in the morning, I'll be down here with coffee, donuts, and whatever the hell we need to do to get this shit fixed. That's what I want to see. So, right. So we got that one. Now, we talked about data. We've talked a ton about data. We talked about learning, using all this done and stuff. Great. Where the hell is it? Where's my data? Because it's my data. It's all my data that's being used. And in my case, I've got some really kind of crazy cool data on engines and flows and all sorts of other stuff that if it leaves my control, I got to put my hand up to all sorts of interesting people and go, oops, I'm sorry. So if I'm letting something see it and I'm letting something use it, does it stay there? Does it move? Do the results move? Do bits of the data move? What happens to the very data you're using? If it's user data that I'm doing for, insider issues or anything else, or heuristics or, behavioral analytics, where does that data live? Because so much of that data is potentially classified as privacy level data, especially European laws and everything else. So really understanding where my data is, what's happening with it, how well is it looked after, where else is it being used? Do you sanitize it and use somewhere else? And all these other kind of conversations. So understanding where it is, understanding what's going on, understanding how it's hosted, understanding obligations, all this other kind of stuff. Now, back to your point and the question you had to me, let's reverse that. If I am buying a product and the vendor says, well, it's got a nice AI engine, the question's got to be why? Why did you build it with an AI engine? What was your logic? What was the reasoning? What was the why force? What was I want to know. Blockchain, good grief alive. We need to do one on blockchain. Well, we use blockchain to ensure the integrity of the transactional procedures, blah, 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 blah. No, you don't have to do that. Why did you do that? So it's challenging the decision matrix of the very vendor. Why did they use it? Because AI and ML are very, very complicated architectures to integrate successfully. There's simpler stuff out there. Fuzzy logic is good enough for most instances. So if you've gone off the deep end and gone down the AI and ML route, I want to know why. What could you have not solved with something simpler? Because hate to say it, quite often the simple solutions are often the best. But there are cases where, and we've already talked about some of them, where simplicity, unfortunately, will run us over like a bloody steamroller. So therefore, we need to be able to integrate, and we need to be able to effectively manage massive data sources, blah, 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 blah. So you want to hear it from the vendor as to why the hell they chose that. All righty. Let's talk about some of those wonderful buzzwords. Let's talk about deep learning, supervised learning, unsupervised learning, methodologies. How does it actually work? This is really where you want to get to the nuts, the bolts, and the guts of this darn thing is. This is where you want to look and go, okay, I mean, this is really where the difference between supervised learning, which is, where and how have you modeled it? How have you built it? Unsupervised learning, what have you done? What rules, regs, and what have you put in place? What have you actually understood as far as artificial intelligence? If you turn around to me and say, well, unsupervised learning is superior to supervised, I'm going to throw a flag. If you turn around to me and say, pre-trained supervised learning and the features, no, I'm throwing a flag. I want to know how much you understand about the different learning methodologies, how each one has its own strengths and weaknesses. And in some case, you want to use both depending upon what you're actually doing with things. So this is really, really where you get to the nuts and bolts. And quite honestly, sometimes you want to make sure that you know enough to call BS. A lot of that stuff is really, really good. Sometimes you used unsupervised to do some rough defining, and then you use supervised to really, really hone in on data. Perfect example would be you got a block of marble in front of you, and you want to eventually end up with the statue of David, where you don't just suddenly chime in and chip in. You rough it out. Welcome to unsupervised learning. Then you get into the finer details and fig leaves. Now you got the supervised learning. So if you think about it that way, just looking at that raw and understanding it, if somebody can explain it that way, now you've got a better chance of them knowing what the hell they're talking about. So that to me is a really, really big one. It's a big red flag if somebody can't actually do that one. So what kind of techniques? So let's have a conversation about basically searches versus rules versus machine learning. So I kind of want to know, another one of those big questions is, do you use rules? Do you use search-based techniques? How are you using? What are you using? When are you using? And really start to look at, and some of this comes to knowing yourself. So if you are doing certain types of security orchestration that has a very, very structured set of methodologies, you want to know what kind of rule-based architecture they're using. You want to know what kind of learning-based algorithms they're using. You want to know how well structured the decision matrix is. So all of these are some really, really good conversations to have. So there comes to be a point where, again, you hit this one, which is at what point do you know that it's ready and you know you should use it or could use it? And we start talking about it. Unfortunately, the wrong way to talk about it is accuracy. Or, how accurate is the product, or how accurate is it doing a certain thing? But, how well is it going to find all of the flaws in my system? Well, I don't know. How well have you actually given me the data to be able to run the analytics on that? The answer is probably not very well. So we start taking a look at we start taking a look at different types of scoring methodology. F1 scoring methodology is probably one of the more effective one. And there's a whole conversation we could have on it. My recommendation, honestly, is go do a little bit of Googling at this point, because nothing's ever perfect. Let's start with the easy one. But what you want to know is what's the mean deviation. Perfect example, the computer that's in front of me and one of the ones that's behind me, when I have a certain headset on, will recognize if I want a cup of tea, will recognize when I'm coming down, will unlock if it knows it's me, and a few other things. It's doing it by taking brain patterns and it's putting them into a 3D matrix, a 3D model. Then it's running analytics on those brain patterns versus what it knows about me previously. Now, those two will never be perfectly the same because I blink or my subconscious is thinking and doing something else. So there's always a deviation. What I've set that deviation to is a 75 to 85% accuracy rating. So as long as my machine is 85% certain that it's me, it opens up. I don't have to use passwords or any of that crazy shit. And it knows certain other things about me. It starts music and lights things and does other things. If it's less than that, it won't do anything. Now, if I set it to 90%, there'll be more opportunity for it to learn, but there's also more opportunity for me to sit here looking like an idiot wondering why my computer's not started up. So when you start taking a look at these are where you want to know how well is this system actually going to be effective in my environment. Because these are not silver bullets. These are not be all end all 100% solutions. So you've really got to look. F1 score is probably one of the better ones to use, but there's other ways of actually doing this to understand how effective is this solution. Because again, shit ain't perfect. Let's talk a little bit. One of the other things is the team. So if you're bringing a vendor in, you kind of want to know who actually had hands-on developing this bloody thing. It's less about qualifications and it's more about experience. It's more about knowledge. It's more about background. When we're building these things into play, I kind of want the old fuddy-duddy in the white coat in there somewhere. I want somebody who spends their waking moments on a whiteboard, redefining how the universe ticks in there somewhere. I don't necessarily want somebody who's got all the qualification that goes with it. I need somebody who's got some experience and some knowledge in this shit. I don't necessarily have to have them on the publish or perish, but I want to know they know what the hell they're doing. So you really, at this point, I don't care about the CEO, the CISO, chief scientist, whatever. I care about the folks that are actually hands-on coding. This is where we get to a diversity conversation, because if your environment is being coded by a certain type or frequency or location or people, guess what? Your results are going to follow suit. We ran into this a number of times. If you look at machine learning and intelligence in vehicle automation, when they were training the initial vehicles, they, for the most part, used people that looked like you and I. When the machine went out and it recognized darker patches, it thought that those darker patches were okay. No, they weren't. They were people of a different color who unfortunately got run over by the bloody vehicle, but thought they were just darker patches, that it was perfectly okay. They didn't train it in a way that they didn't think. So again, look at the people that are building it and designing it. You want to have a diverse team. No offense or buts about it. Couple of other conversations. Not all AI and ML solutions are prime time. So a good conversation to have obviously is who's got this running and can I talk with them? And who has it running in proof of concept versus who has it in learning mode versus which companies have handed the keys to the kingdom over and they are letting it do its thing. So I think that's another good one. It's a short and swift one, but it's a fairly useful one. Now, we go right back to the very, very beginning. You hopefully had identified what your process was that was missing that needed to be solved with an AI ML solution. So how are you going to measure effectiveness? How are you going to know that this thing's actually doing what it says it should be doing? So what's your return on investment? How have you actually established that this is successful or not, as the case may be? Is it that you're not running around like a blue-ass fly? Because you can turn shit off and you're not running around like a blue-ass fly. Yay, success. Perfect measurement. I'm not running around like a blue-ass fly. Or is it a risk profile score? Or is it a metric score? Where are the scores that you are going to use to actually determine on this one? Now, let's go back to that whole ROI conversation as well. Let's face it, if you actually realize that this silver bullet that you're hoping for actually needs to learn. So you drop an AI solution in place and it has to learn intelligence, or it has to learn threat modeling, or it has to learn behavior, or it has to learn my security orchestration. You have to understand from those organizations, what is the time and necessary requirements in order to recognize that return on investment? Are we talking a month's worth of training? Are we talking 6 months? Perfect example on this one. So years ago, we used to have all the application firewalls and all these other things, and we didn't put them in line to begin with. We put them in an ARM mode, or we put them on a span port. So we let them learn. We let them watch the network, and we let them learn what was good, what was bad, and what was ugly. And you had to let it learn for a period of time. The vendor was like, hey, you need to learn for, a week, a month, a day, or 6 months, or whatever. So that same conversation needs to be had with any intelligent solution is how long does that have to learn for? before it can become effective. We managed to get through 17 questions in a reasonable amount of time. Kind of crazy, isn't it? We haven't dug the rabbit holes of AR/ML. We did a mile long and an inch wide on this one.
Yeah. Well, I hope this was useful. So let's just kind of recap. TLDR or TLDL. One takeaway or for listening to these questions for the audience today.
Nothing's infallible. So first and foremost, do not put a solution in place and expect it to be more perfect than you are. I think that would probably be the best one. That's the best one. Expect to put a solution in and have to train it, kind of like you do with humans. It's the same thing. Expect to put a solution in and have to sit down and understand how it works. But the other big one is expect to invest time and energy and effort in order to be able to recognize those returns on investment. It's that effort in, effort out, or effort in, reward out, whatever that matrix model thing is. Those to me are the big ones. It really doesn't matter what you're looking to do. It doesn't matter if you're looking to put a decent autonomous, semi-autonomous threat intel, human intel, machine learning, algorithmic system to look after your orchestration stuff, or it doesn't matter if you just want to play chess with something. Even if I've got an AI solution that I want to play chess with, it has to learn me. Once it's learned me, well, then it's got to learn my nuances, my Tuesday morning habit versus my Wednesday night habit. The fact when I've had 2 drinks, I make less advanced moves. When I've had 3 drinks, I'm not thinking 7 moves ahead. I'm only thinking 2 moves ahead. So when you think about it that way, if I train it and I help it understand me, it's going to have a better chance of actually doing the right thing. So it's no different than we put it into systems. So be wary of any vendor that says you just implement it and it's fine. You're welcome. Yeah, it doesn't work that way. Never has, never will do.
Right. There you go. All right. This has been our second top 10-ish. And the next one's going to be awesome.
This was AI and ML for me are one of those really, really cool. Because again, it's all math. It's all about the mathematics. And yeah, well, let's face it, math geek. So next up, the cloud. Conversations and 10 things to have conversations about with that. Good grief alive, we're going to have some fun with this one.
Amazing. Well, as always, this has been a pleasure.
Yeah, Danny, as always, thank you. Like, seriously appreciate it for putting this together, getting it on, kicking my ass sometimes to make sure I actually do the right thing at the right place at the right time, preferably the right way up. And to everybody listening, I hope everybody's enjoyed it, and see you all on the dark side.
Thanks for tuning in to this episode of Dr. Dark Web. This show is brought to you by Cyber6Girl, the threat intelligence company. If you would like to learn more, please feel free to follow or subscribe to Dr. Dark Web on your favorite podcast streamer. Or, as an alternative, you can always find us online at cyber6girl.com/podcast. You'll find all the latest episodes, goodies, nuggets of information, background, and probably some stickers or two. See you in the dark.